Hi there, this is Jeff. I'm super excited to share our CVPR 2024 paper, FlowVid, Taming Imperfect Optical Flow for Consistent Video-to-Video Synthesis. This work is done with co-workers from UT Austin and Meta. We are proposing a video diffusion model to transfer an input video to a new synthesized video with language prompts. Our model can do global sterilization, such as rendering the video into a Chinese ink painting or flat 2D anime. Also, we could swap the subject in the video, such as replacing the panda with koala and woman with Greek statue. Let's first start with image-to-image synthesis. There are many good image-to-image models, such as ControlNet. Based on some abstract controls, such as Canny Edge, ControlNet could synthesize a valid photo that follows the guidance. It was used to be extremely hard to draw out. Now, after drawing two simple cycles, the ControlNet could do the rest for you. However, directly applying ControlNet to video could produce inconsistent outcome. For instance, we want to transfer a video of a SUV into one ghost style. If we look at the first frame, it looked great, right? We transfer the second frame, it also looks great. But if we look at details like the color of the car and the road, they are totally different. If we stack all these frames together, it will be very flickering. However, we don't want to discard ControlNet because it's too powerful. We then formulate the video-to-video task into two steps. First of all, we edit the first frame using image-to-image models like ControlNet. Then we'd like to propagate the edit into the entire video. Then the problem raises how to propagate the edits. Actually, the optical flow within the video could relay the pixel correspondence between frames. So therefore, it might be useful for propagation. For example, if we have 4 frames, and for the frame 2, we perform flow warping to the frame 1, we will have the warped frame 2, which has the exact layout as frame 2, but has some blank regions. These blank regions are occluded regions in the frame 1. We could also do this for frame 3 and frame 4. We could see that occluded regions, the blank regions, is actually getting bigger. Great! Now, thinking that we have added frame 1, which is obtained by using ControlNet, we could reuse the optical flow in the input video to do flow warping. We could have warped edited video to frame 3 and frame 4. But still, the warped video is not a valid video, right? Because there are many blank regions inside. So how could we inpaint these blank regions to make them valid videos? We propose to train a video diffusion model taking 2 types of conditions. One is spatial controls like depth or canny to provide the layout of the video. The other is the temporal control, our warped video on the top left, which provides the most texture pixels. After training, we first obtained edit warped video as introduced before. Then we put the edit warped video and the new prompts, as well as the spatial control, all together into the trained FlowVid model. Then we could synthesize a good video. Here, we provided a quantitative comparison with existing methods. For per frame ControlNet baseline, we could observe very severe color jitterings across frames. For codef, the videos are always blurry. For re-render, the paddle sometimes disappears. The token flow is the most competitive method, but sometimes fails to follow the prompts. We also did a user study containing 25 Davis videos and 115 prompts. Each user is presented with 4 videos and is asked to select the best video. Our model achieves the comparable performance preference rate with token flow. We also test the runtime to generate a 4-second video with 30 FPS. Our model is much faster than existing methods. Thank you all. Check more video results on our project page. Thanks.